In this wind tunnel laboratory, we're going to measure and visualize the flow of a supersonic diamond aerofoil. In the first part, we're going to go through the experimental setup. There are 4 objectives to be achieved through this wind tunnel laboratory. First is to experience a supersonic wind tunnel operation. Second is to measure pressure through the U-shaped manometer. Third is familiarize with Schlieren Visualization. Fourth is to observe the shock wave and expansion fan. Showing here is a supersonic wind tunnel. It's a small one, and I think also it's a historical one. It has been in this laboratory for more than at least 50 years. It's an induction type wind tunnel. So we have the high pressure ejector in here. You can see the 2 high pressure pipes. They will produce 2 high-speed jets in an ejector. And the supersonic nozzle is inside this metal wall. We can't see it, but it's a convergent divergent nozzle. Then the flow is driven through the nozzle, so the flow direction is from left to right. And you can see 2 meters in here. The first manometer indicates the pressure inside the tank, so it's around 7 bar, showing here. If in the laboratory, you can read it as 108 psi. So the second manometer indicates the pressure in the ejector. So in the experiment, we are expected to fully open the valve in here. Okay, you can see the wheel in here that regulates the valve. Now you can see the test section is highlighted. We can see a window, and there's an aerofoil inside the window, and we will have a close-up view later. And there is a handle connected with the test section, so it's used to adjust the angle of attack of the aerofoil model. And so this is the close-up view of the test section. We can see the window, and it's fully transparent. And if we zoom in further, we can see the diamond or wedge aerofoil has a wedge angle of 10 degrees. And on the side, you can see a indication line, and that's used to align the angle of attack. On the left side, you can see a angle meter, and the range is from -10 degrees to +10 degrees. So once the indication line is aligned with whichever line, you will know the angle of attack. So this device is used to check the angle of attack or set up the angle of attack. So the second part is to measure the pressure. So we have a lot of pressure tabs inside the wind tunnel, but in the experiment, we are not going to use all of them. So we can see the hoses connect to the pressure tabs on the wall. You can see the manometers, and they are filled with mercury. So when we operate the wind tunnel and read out the readings, we should be very careful. So in the experiment, we are going to take 3 readings. The first is PS, it's called stagnation pressure, and the measurement is inside the settling chamber as highlighted in here. Accordingly, it's number 21 of the manometer. So PS is the total pressure in the wind tunnel. Because now we can see this wind tunnel is induction type wind tunnel, the total pressure should be very close to the room pressure. So the total pressure is not so high. And also we have P infinity, which is manometer number 23. So P is, where is it? It's actually on the test section wall, lower wall. So it's manometer number 23. So knowing PS and P infinity, we can use this relation to get the Mach number. The design Mach number of the supersonic nozzle is Mach number 1.8. So through the measurement and doing this calculation, you can compare with a theoretical design value whether there is a discrepancy. And also we have P, which is the manometer number 22, and that's the pressure on the lower surface downstream panel. And here is showing a close-up view and taken from the lower side of the airfoil. You can see there are two pressure taps. One is on the leading edge, the other is on the trailing edge, both on the lower surface. And actually we are taking the measurement on pressure tap number 2, which is P. As a summary, and we can see the diamond of wedge aerofoil is placed in the middle of the wind tunnel, and the wind tunnel has a test section. The height is 4 inch, the width is 1 inch. Basically it's about 100 millimeter by 25 millimeter. That's a test section cross section area. Okay, and the wedge has a angle of 10 degrees. The side has a length of 15 millimeter, and the aerofoil is placed at the center of the test section, so it's 50 millimeter from the wall. And we measure P infinity, which is basically the static pressure at the wall or in the free stream. And also we have the pressure tap at the lower panel close to the trailing edge, which is indicated by P. Okay, so we've seen the wind tunnel and also the pressure measurement. The third step, or the third equipment we are using, is the Schlieren Visualization. And you can see here is an LED, and we have a concave mirror on one side of the wind tunnel. Schlieren Visualization is actually an optical method, very delicate optical method. I'm not going through the detailed principles, but give you just a brief understanding about this visualization system. Okay, so the LED is used as a point light source, and it will emit expanding light. So once it hits on the concave mirror, and because of the LED is placed at the focal point of this concave mirror, and then the mirror will collimate the light into a parallel beam. So now let's move to the other side of the wind tunnel. We have another identical mirror. So this mirror is identical as the other one on the other side. And also we have the knife edge and the camera. Of course, the camera is equipped with a lens. In this case, is 36 mm lens. Okay, now we have the beam, collimated beam. And since it's a concave mirror, it will focus parallel light onto the knife edge. So the knife edge is placed roughly at the focal point to cut part of the light, and then the light will go into the camera and form the Schlieren images. Okay, so now we have the view, close-up view of the test section again, and we have the Mach 1.8 flow, and we are expecting what kind of phenomenon? Yes, that's a shockwave. So in the next part 2, we are going to talk about the flow measurement and the visualization. what kind of results we are expecting.